We thank you for this new wonderful day in our life. We stand before you in humble before we start our program. Without your blessing and grace, all these plans would not have come upon this. Let your grace, divine wisdom be with all of us throughout this exhibition and this invitation talk, so that we can cooperate, enjoy, and love one another and glorify your mighty name. Hide us and let your name alone be glorified. We ask everything in the name of our Lord and Savior Jesus Christ. Amen.
Amen. Thank you, sir. A warm welcome to one and all to commemorate Vigyan Sarvatra Pujyate Festival of Scope for All. This week, we are going to witness a great event happening in the American College. Yesterday, we inaugurated the Science Festival, and today we commemorate the event with the theme Highlight on the Annals of History of Science. Science is at the threshold of change. It waits to take off into a great and dynamic future. India has a rich heritage of science that evolves along with advances in knowledge and technology and with societal concerns. As our illustrious former president, Dr. APJ Abdul Kalam stated, dream, dream, dream. Dreams transform into thoughts and thoughts result in action. Yes, we are called to dream the dreams, wide awaken with inexhaustible dynamism. And now it's time to welcome our honorable guests. I am delighted to welcome our beloved principal and secretary, as well as chairman of this great event, Dr. M. Davamani Christopher, who takes simple gestures with a meticulous stride of sound and steady progress. My hearty welcome, sir. And it gives immense pleasure to welcome Dr. G.C.
Great, yes. Respected chief guest of today's program, Shri J. Asir Packiyaraj, the outstanding scientist and associate director, IPRC Mahendragiri, Bursar Dr. Dorothy Sheila, Dr. John Swami, and IQC director, Dr. KG, Dr. Gnanasegar, the deputy coordinator, Priyadarshini, the faculty, and my dear students. It's my pleasure to be here with you all on the wonderful day. This entire program is in YouTube now. It is in online now. It is going online. So everyone is watching you all. It's a great occasion. So they have chosen 75 places all over India. One among the 75 is American College. It's a great honor to the college and of course to the students and faculty. Today we have two sessions in the morning. One is Shri Asir Packiyaraj. He is from Mahendragiri, being a physics student. Who are all here, sitting here? Physics PG? Then UG? Third year? Great. Chemistry also. UG or PG? See, I'm proud of you people. Recently, one of our students invented a solar bicycle. See here, Tanush? He's in the lab. So recently our student, first PG student, he did his UG here in Americancollege. He invented one solar bicycle. I'm proud to say that we have a lot of young scientists are here. The forthcoming Abdul Kalams are here. Yes, forthcoming Abdul Kalams are here. We are going to achieve many things. See, wherever we go, we can see the alumni of American College. நேற்று பேசும்போது சார் சொன்னாங்க இல்லையா, ஐஎஸ்ஆர்ஓ இருந்தாலும் சரி, டிபிடியாக இருந்தாலும் சரி, எங்கே போனாலும் அந்த சீனியர் பொசிஷன்ஸ், அந்த சீனியர்ஸ் வந்து நிறைய இடத்துல வந்து அமெரிக்கன் ஸ்டூடெண்ட்ஸ் இருப்பாங்க. அதை பார்க்கும்போது சந்தோஷமாக இருக்குது. அதனால் அவங்கள யங் சயின்டிஸ்ட்னு கூப்பிடுறேன்னு சொல்லி சொன்னார். சேர்மன் ஆஃப் தி ஏரோநாட்டிக்கல் சொசைட்டி ஆஃப் இந்தியா கன்னியாகுமரி பிரான்ச். He is also president of Indian Society of System Engineering Kanyakumari branch. At present, he is an outstanding scientist in ISRO and associate director of ISRO Propulsion Complex Mahendragiri. Friends, science of today is technology of tomorrow. We have one of the biggest scientists in India and South Tamil Nadu, South India, Shri J. Asir Packiyaraj, the outstanding scientist. It's a great opportunity for all of us to have Shri J. Asir Packiyaraj with us. I thank the organizing committee for organizing him to be with us today. Thank you for your listening, patient listening. Great. Congrats. God bless.
Thank you, sir, for introducing our honorary guest. Today's great moments are tomorrow's wonderful memories. Mementos are reminders of those great moments. I invite our principal to honor our chief guest with a shawl and memento. Thank you, sir. The greatest thing to be learned in life is willingness to learn. I now invite Dr. K. Gnanasekar, Head, UG Department of Physics, IQAC and NAC Coordinator, to moderate the session. Over to you, sir.
Young friends, I welcome you all on behalf of our college. Today, fortunately, we are having amidst us a great scientist, outstanding scientist, and associate director of ISRO, one wing of the ISRO. They are concentrating on testing liquid propulsion part of the rocket. The many rockets our nation has launched, they have contributed. The scientists that today we are having actually directly involved in testing the important parts of the rocket that have been launched for many years. So already our principal have introduced the speaker, today's speaker. So on behalf of all of you, now I call upon today's chief guest to deliver his address. After that, even in the middle, I hope our scientists will accept it. You can interact, and we should have a participative discussion that always will help us, because all who are sitting here going to be the future scientists. So you have the ample opportunity to interact with the various things that is going to be shared by the today's speaker, the outstanding scientist and associate director of ISRO wing.
I feel privileged to stand before this august audience. Respected principal of this institution, the vice principal, the program coordinator, the co-coordinator, the Bursar ma'am, and all the Professor Janasekar, the teaching faculties and the students. Don't look at me as a scientist. I'm not a scientist. I'm one among you. I feel still I'm a student. Wherever I go, I keep learning things. Learning is life, and life insists on learning. So keep learning. That takes you to greater heights. Greater height doesn't mean that you become associate director or outstanding scientist. That's not a greater height. Greater height is be a person who is adding value to the system where you are living in. If you are living in a family, add value to the family. If you are there in a classroom, add value to the classroom by making some whistling, pinching your friends, fighting, making noise. And if you are there in the society, add value to the society. So kindly don't stare at me, I feel very uncomfortable. I'm one among you. So I had completed my mechanical engineering and then I joined ISRO in the year 1986 after completing my graduation, and then I keep growing along with ISRO by contributing for ISRO. So the given time for me must be around half an hour, I understand. Am I right, sir? Okay. So let me see, I pray God that I wish He should keep in my mouth useful subjects for you and the appropriate words which can communicate the message to you. So basically, space has got a lot of potential. This program has been organized for promotion of science among the students community, as the principal had introduced. They have chosen about 75 institutions across the country, and you are privileged to be one among the 75 across the country. Let me greet the American College here at Madurai. I think you abbreviate it as AMC, am I right? American College, AMC. Let me also abbreviate it as AMC. So you AMCNs are highly privileged to have this function in your institution for this week, I understand. No, it's a week-long function. So you have very wonderful institution and the management here, led by the principal and secretary, Dr. Davamani Christopher, and the host of the professors who are shaping our career. I always, as a person working in the research institution, we have a lot of interaction with academia. So we give project work to the students, especially we have been going to Indian Institute of Technology and Indian Institute of Science in Bangalore, and some of the National Institute of Technology, and some other institutions who are willing to join our hands in adding value to our system. So I feel we are privileged to have a good academia in our country, and I would say that you are the backbone of the country, sir. The way in which we grow, without the academicians, we are nowhere, and we will be rudderless. And in fact, whenever we have some tough assignments, when we are not able to resolve ourselves, we come back to the institutions, we discuss with the professors and find solutions and then keep going ahead. So you are privileged or blessed with such a host of, I would call teachers in a generic term, host of teachers who are shaping your career. And my career was also shaped by some teachers like them in my childhood and my youthhood, and when I entered into the institutions. And now when you work in an institution, now every colleague is a teacher for you. You keep learning from your own colleagues, and sometimes your own family, your own siblings, your children. No, for our case, we keep learning. So, like in the earlier years, 1960s, the government of India had a good vision. I mean, the India had a good visionary by name Vikram Sarabhai. And he was basically a nuclear scientist. He hails from Gujarat, and he was a multimillionaire, son of a textile industry owner. The family was running a textile industry by themselves. And he was a multimillionaire, and he was a nuclear scientist. And then when the United Nations started interacting with various countries, you are geographically, you must be clear about the latitude, longitudes, equator, no? They are all our fundamental things. Like you have the equator. சில பேர் தமிழ் மீடியம்ல இருந்து வந்திருப்பீங்க. ஸோ ஐ தாட் பூமத்திய ரேகை இல்லையா, அல்ல நிலநடு கோடுன்னு சொல்லுவோம். அப்புறம் அட்ச ரேகை, மகர ரேகை என்ன சொல்லுவோம், latitude and longitude. So they are all very important for the earth. It's the identity of the earth, how to identify a place on the earth, you need like your door number and street name, you require the lat long for the identification of a particular place on the earth. That we call latitude, longitude, your x-axis, y-axis. So you find out, strike a point, and that is your place of identity. So you need, earth is having such a grid formation, it's an imaginary grid formed over the earth, lat long. And now along the equator, it's generally called a tropical zone. We have a lot of changes in climate, and so the United Nations wanted to have a observation of the change of climate by having different sounding rockets. That means, they go up to an altitude of about 100 kilometers and then keep dropping the payloads, which are the sensors basically, which measures the temperature, wind speed, the humidity. All those things are measured while the payload is getting dropped. So this experiment was started by United Nations, and in India, one place was chosen. That's called Tumba. So it's called Tumba Equatorial Rocket Launching Station. We call TERLS. So the Tumba was chosen. It's in the state of Kerala. It's a seashore. It's a hamlet along the Arabian Sea. So they chose that particular place for taking up these rockets. So when in India, the Nuclear Energy Department was identified as the coordinating department to coordinate these activities with the UN. So then the chosen person was Dr. Vikram Sarabhai to coordinate with the UN. And when these activities were going on in Indian soil, that visionary, he had a great vision. When the entire world, by the time the Americans were working for their Chandrayaan program, their moon landing. Okay. So they wanted to take people to moon, and they want to have their astronauts on the moon in the 1960s. At that time, same time, this equatorial rocket launching program also started. Can you go to the next page? Next. Do I have a remote here? No, I don't need. If somebody can help me. Can you go? I think we have skipped a couple of slides. Can you go back? Go back? Go back? Go back. What you're reading here is the potential of the space should be used for every human being, and there should be the usage of space. I'll come to you why space is useful for you. When you watch from space, see, when you go to the first floor balcony, you see more things. When you go to the second floor balcony, you see little more things. When you go to a 12-story building, you see little more things. Recently, I had been to Dubai. So there are tall buildings, when you go to, you will feel like touching the sky. So it's the tallest tower is there. I forgot the name of the tower. Burj Khalifa, yeah. I went to that Burj Khalifa, but it's about 167-story building, but they allow only up to 100 stories. They are charging us, and then you have to just go and look at the sky, that's all. So when you go away from the earth and keep looking at things, it's called remote sensing. When you are touching here, it's sensing. When you are going away and sensing, it's called remote sensing. I look at each and every one of you like a sensing or a partial remote sensing, but you go much away and keep sensing. That's called remote sensing. So when you remote sense, you can see half portion of the globe. And if you fly over, if you keep an object, a camera, and go above and watch, then you can see most of the country's surface. Am I right? when you go to the second floor or third floor, you can see only this road. What is the name of this road? AMC road? Gauripalayam. Okay. But when you fly in your flight from Madurai airport, you can see the entire Madurai. So when you fly higher, further, you can see, one half of the globe can be seen from a distance. Am I right? Like half of the ball you can see the Earth. Similarly, when you go away from Earth, with very clear resolution cameras, you can go for remote sensing. And that is one use of space. Then another thing, when you see the Earth, there should be light also on the Earth. So you should synchronize yourself with sunlight. So you call it as Sun Synchronous Polar Orbit, SSPO. Would have come across many, the PSLV places the satellite in the Sun Synchronous Polar Orbit. That means, you are going through the pole, Earth is rotating east-west, and you are making a scan across the Earth, but you should come to your point of interest when light is there on the Earth. So like I met Professor John Packiyaraj at 8:45 in the morning. We synchronized. I started from Nagarkovil. We fixed the time. We know the odometer. You know the speed at which you are going to travel. At Tirumangalam toll gate, what is the distance? So we fixed a time and we got synchronized. And he guided me further how to reach your AMC. So like, you are synchronizing with the Earth when the daylight is there on the Earth and keep photographs. And when you take photograph, you can take any damn thing. You can take photograph of a water body. You can take a photograph of a field, a forest, a fire. And you can also take photograph of your neighbor. Am I right? So for strategic things, what is happening across your border, you can take photograph and you can. Beauty is on beholder's eye. Whatever you look at, you want to look, you look. So then when you are looking, the clouds are coming. So when on a cloudy day, you are not able to look at the Earth's surface. So you have to go for remote imaging satellites, radar imaging satellites. So RISAT we call. So you have to see through the clouds what is happening below the cloud. So then, okay, this is one kind of remote sensing. It's called polar satellite. North pole and south pole are there. You come across the poles. Earth is rotating like this, and you come across the poles. And there are, I don't want to go through the entire material. You may not find time. I leave the material here with the departments, and you can go through. And then when you go above and start using the transponders, and you transmit back to the globe, your the telecommunication. So you need not have hardwired cables all along the Earth. So radio waves, so electromagnetic waves. So you keep communicating back. So that becomes a communication satellite. But for communication, you can't synchronize. If you are synchronizing for 20 minutes or 30 minutes in one particular orbit, you will be able to have the communication only for that 20 minutes in a day. Then you have to wait for the next day to wait for the synchronization to happen, and you can't have a continuous communication. So then how to have a continuous communication? You have to geosynchronize yourself. You have to synchronize yourself with the Earth, always. It's like two parallel moving trains, two parallel tracks. If they move at the same velocity, they appear to be stationary with respect to each other. So what we call geostationary satellites. For that, what we do, we go above the equator, that is the center plane of the Earth, and at a particular altitude, you have the tallying equation. At a particular altitude, you need to have a circular motion around the Earth, so that centripetal force and the centrifugal force are to be nullified. So you get a resultant circular motion. And then, at the same time, the period of rotation also should be, no, don't tell me at kilometers per hour. The period of rotation of Earth, tell me, 24 hours. So your period of rotation of that particular satellite in that orbit also should be 24 hours. So you have to balance the force and the time. So achieve the altitude of the orbit. You understand? It's very simple for you. You are physicians and physicists and mathematicians, and chemistry also must be having ancillary mathematics. So you must be able to, it's a very interesting calculation, no? You have to balance the force and the time. So you decide the orbit. altitude. So the velocity, if I convert into angular velocity or period, it becomes 24 hours per rotation. So when you keep a satellite away from the Earth at a particular altitude, balance the force, so that satellite is always stationary with respect to Earth. Am I right or not? Earth is rotating, you keep another satellite at the same angular velocity, balance the forces. It is approximately at 36,000 kilometers. It is 6 times of the length of India. That is the altitude at which these communication satellites are placed. Then that particular satellite is stationary with respect to Earth. So you keep making use of the payloads in the satellite, the transponders in the satellite to communicate, get it, receive it, amplify, and then send back to the Earth. So that the half of the Earth can get that communication. That is one thing. And apart from these things, when you go to the orbit, whether it is a remote sensing satellite or a communication satellite, I mean, communicating properly, the response looks to be very, it's okay. Should I talk in Tamil, you feel? It's okay. Purida? Can I go ahead? I hope you understood remote sensing and you are now understanding the communication, geostationary. And this geostationary, any satellite when it goes to orbit, any satellite must be of a cubical structure, It's a 3-dimensional structure. It has got any solid object has 3 dimensions. So X, Y, Z. Now when you go to the orbit, assume my satellite has all the transponders in this side. I'm supposed to orbit like this. My satellite tumbles and it goes away like this. What will happen? It is there in the appropriate place, but like many of us when we sleep, we are inside the classroom, but the use is not there. We are in our chair only, staring at the teacher, but we are not useful. So you have to look at like this. So you have to tumble the satellite, you have to control the satellite, or you have to orient the satellite. The attitude and the orbit should be oriented properly. So for that there are some control, you have to give some control forces, that's all. I will talk in your language. So you need to have control forces to rotate it this way, you rotate it this way. Whatever orientation you want to do, you need to have control forces. Assume the satellite as a cuboid. It's a frame as a cuboid structure. Then you have how many corners? 8 corners. So you should have 8 thrusters, which can give control to make the cuboid in the appropriate orientation. Only for a redundant purpose, anything can fail, like our power failed in the morning. Such things we can't afford to have a failure on board, on a satellite. So any system on board should have, on board means on the spacecraft or on the satellite, should have a redundancy. Sometime, you have a dual redundancy, you have a triple redundancy, even more also sometime. If it's a Gaganyaan mission, like, when you are carrying man to the orbit, you should have multiple redundancy. So nothing should fail. So as a double redundant system, for 8 corners, you have 16 control thrusters. So even if one fails, the other will take over. And to give control or give a control force, you should have a propulsion system. So there are small, tiny rockets which are sitting in the spacecrafts. And to make the rockets to burn, you need the propellants, am I right? The fuel and the oxidizer. In your automobile in the Earth, you carry only the fuel, either a petrol or diesel. But on the orbit, you don't have oxygen for combustion. So you need to carry your oxidizer also with you. For all the rockets, they don't work on air. They are not air breathing. So they are only fed with both the fuel and oxidizer by itself. So you need to have a combustion. A controlled combustion happens. So to have a controlled combustion, you need to have valves which respond to your command from the ground or from on board. So those valves should be open for milliseconds, because they don't have a friction, they don't have air drag, they don't have a G at 36,000 kilometer altitude. No such natural forces are acting on them. So you need to have very, very micro control systems only you need to have. So you need to have on-off valves and other things. So to operate those valves, you require command system. You have some algorithm written. If this much theta variation is there, my force should be this much kgf. or Newton. So your theta, you should write an algorithm to convert into your Newton. So all such algorithms are written. So why I'm telling you, you're all students, you must be trying such mild, very minute algorithms in your project or in your thesis activities. It will be interesting for you. Just think of a problem by yourself, try to resolve it by writing algorithms. Okay, so now this is the fate of a spacecraft sitting for 15 years. And now the world is fast improving. The mobile, when you people see my mobile, you will be looking at me as an outdated man. I have some J6 of Samsung, some 3 years old model. So now in 3 years on the ground, the technology grows. But when you keep a satellite on the space, that satellite, with you are investing about 1,000 crores for building the satellite and the launch vehicle which carries the satellite to the orbit. And now the technology what is available inside the satellite should be having advanced technology. You can't have outdated technology, but that is going to work in space for about 12 years, 10 years plus. So you should think very positive, foresighted. So all the payloads which are getting into the spacecraft should be advanced payload, because you have a preparation time, you have a launch time, then it has to work for 10 years. By the time you launch and keep in the orbit, if the technology is outdated, it's not useful to you. So all these system engineering concepts should get into the preparation of a spacecraft. So this, and then human mind is always having a quest for knowledge. இல்லையா, நமக்கு என்ன சொல்றது, அறிவு பசி, நிறைய என்னெல்லாம் நடக்குதுன்னு தெரியணுங்கிற ஒரு ஆர்வம் நமக்கு இருக்குது. You have a quest for knowledge, to know about what is sun, what is earth, what is the limit. So you need சந்திரனுக்கு போனால் எப்படி இருக்கும், சூரியன் பக்கத்தில் போனால் எப்படி இருக்கும், அதெல்லாம் நம்ம தெரியணும் இல்லையா. சோலார் ஃப்ளேர் எப்படி இருக்குது, how they are addressed, so you have to quantify them. So அதுக்கு நீங்கள் you have to go near those planets or satellites or stars. So அதுக்கு வேண்டி then you are having some programs like Chandrayaan. So you go to, நீங்கள் Chandrayaan 2 watch பண்ணியிருப்பீங்க இல்லையா, as your school students or UG students you would have watched. Finally, when we were about to land, there was a small error in one of the program, and then we had a hot crash on the moon surface, lunar surface. So we could not place the rover properly on the surface of the moon. But still the orbiter is working. அங்கிருந்து போயிட்டு you have to have a transition. Something like, it was a very interesting phenomena. Like you are trying to make a bigger circle, இந்த தோசை ஊத்துன மாதிரியா, like நடுவில் கரண்டில இருந்து மாவு ஊற்றிட்டு and you widen the தோசை இல்லையா, அப்படி வெளியில் விளிம்பு வரைக்கும் வருவீங்க டாவால். அதுபோல் you have to make the orbit, you have to go around the earth, you have to go wider, so that you are trying to escape from the gravity of the earth. Then take sun as the reference. Till you are there in the geo orbit, you take earth as the reference and keep going. Now, why I'm telling these salient points are all, you will be working on these things in your projects. Then you have to escape from the earth. Then you are something like an object which doesn't have a reference. Earth is lost, moon we don't know where it is. So you have to have a reference with respect to sun. So it is, we call geocentric orbit, escape, go to heliocentric orbit, that is reference take as sun. So you have sun sensors in your satellite for sensing sun's position, and then where you are. Then you keep moving towards the moon, and the launch date also is fixed for a nearest arrival of the moon near the earth. So then you go and show your face to the moon. Then don't jump into the moon like getting into the swimming pool. So you have to turn your back, slowly land on the moon. You have to show your leg and land on the moon. So when you get into the moon, it becomes a lunar centric orbit. Then you keep, when you escape, you need to give a force in the direction against the gravity. Again, when you enter also into moon also will attract, Moon's gravity is almost about 1/6 of Earth, you are aware. If you weigh 60 kg here in Earth, you will be weighing 10 kg in moon. So your moon will have 1/6 of the attraction of the Earth, 1/6 g approximately. So you need to combat that force also. You need to fight against that force. Otherwise that force will pull you and you will have a crash landing. So you have to have control thrusters or reaction thrusters to fly or to apply a brake on your system to slowly land. So this is how the Chandrayaan mission was accomplished. I'm telling in few sentences, but you think, imagine a situation like this. So how many field of science need to be involved in creating a module of this nature? How many field of engineering need to be inculcated for getting a module of or an activity of this nature? You should imagine. I'm just giving you some teasers. You think of it, that's all. And now, these are all the scientific experiments. So I told you, remote sensing, communication, and scientific experiments. So these are all different places where you go. You go to polar orbit, you need to go to geostationary orbit, or you need to go to neighboring planets or stars. Now, how to go? You need a vehicle to take your spacecrafts. Spacecrafts are the real experimental platform, but these experimental platforms have to be taken to an appropriate orbit or its destination by a vehicle, what we call as a launch vehicle. No? It's a rocket. In a layman language, we call it rocket, but it's a satellite launch vehicle. So we call something like PSLV, the Polar Satellite Launch Vehicle, GSLV, Geostationary Satellite Launch Vehicle, and you call Mark II, Mark III, like, some heavyweight, phantom weight, based on the capability of the rockets. Some rockets can carry about 2,000 kilogram. PSLV can carry, for a particular orbit, if I make use of PSLV, it can carry a payload of about, or a spacecraft of about 1,500 kg. If I make GSLV for that purpose, then it takes about 2,500 kg of payload. So that means if the spacecraft weight is going up, you can take more payloads. The experimental platform can be a broader one. It can be a bigger one. It can have more experimental platforms, more camera, more transponders, more transmitters. So that will make the satellite more costly. And now, if you want to have still higher capable satellites, for example, I want to handle about some 20 channels of TV in a single satellite. My satellite need to be sized to certain level. If I need to handle about 40 channels, my satellite need to be of a different nature. So we basically in ISRO, we have 1K, 2K, and 3K. There is 1,000 kg frame, 2,000 kg frame, and 3,000 kg frame. So these satellites are to be taken by these launch vehicles. And these launch vehicles, basically, I told the PSLV, GSLV, and the Mark III. And these launch vehicles, basically, they work on the chemical propulsion. So far I was talking more of physics. Now I'm going to entertain the chemistry students also. And now it starts with it begins with metallurgy. You need to have casing. You need to have the propellants, which are basically the fuel. It's a mixture of fuel and oxidizer. You need to handle them very safely. It should not, when propellants are cast into the cylinder, what you see, you are seeing cylindrical structure only. The solid propellants are cast into the cylinder. You should handle them very properly. There should not be any spark during the filling operation. If a spark is there, that itself can become an explosion. It becomes a bomb. And the place where these propellants are handled will be totally devastated. So you have to be very careful in handling these propellants. And then the casing manufacturing, the casing should withstand the pressure. And then it should work for some time. So for that, you need to do proper static testing to ensure, for example, I want to reach a particular altitude with a total integral thrust of something like, say, 10,000 tons. That is, I want to have 100 tons operated for 100 seconds. Let me say, so I need to test it in ground, that it is going to burn with a particular burn rate. Generally your statistics of your Diwali rockets, it goes to about 50-meter height. So repeatedly any rocket will go to 50-meter height. They are all tested. So similarly, the booster which carries the satellite from the ground, that should work up to certain particular kilometer. It should go with a particular velocity. So for that, the burn rate is important. So the burn rate, the combusted product which is coming out of the rocket is expanded through a nozzle. So the property of the nozzle is, it's a isentropic, something we call isentropic function. It converts the pressure energy from inside the combustion chamber into kinetic energy. So at the exit of the nozzle, such a huge mass with such a kinetic energy when it is coming out, the product is momentum. mass into energy. The energy is a momentum. So that momentum is nothing but the thrust. By the Newton's third law of motion, the vehicle keeps moving up. This is a simple principle of any rocket engine. So then there are different grades of propellants based on the performance of the propellant. So all these things are configured very fantastically in any launch vehicle technology. And this chemical propulsion, it's basically a solid rockets. They are all designed. So they are all tested before flight. Thorough testing, extensive testing is done before flight to ensure that your flight will perform very properly at a particular payload. See, for example, you think the first stage of the PSLV rocket should fly for 100 seconds. So then you can imagine the accuracy with which the motors are made, solid motors are made, the casting is done. So the band rate should be constant. Then only it can, it will be acting as a rocket. Otherwise, if it is fast burning, it will become an explosion. So now coming to the liquid rockets. For under the chemical propulsion for the solid rockets, if you ignite, the entire solid will burn through. It will burn. You can't stop the burning in between. But if you go to a liquid rocket, where you carry some liquid fuel and liquid oxidizer, you can control the flow rate, you can regulate the flow rate, like you want to go in third gear, or fourth gear or first gear. You can control or throttle your speed by controlling the flow rate of the propellants. Yeah, I'll come to liquid hydrogen also. So liquid, other nitrogen tetroxide, and that will be the oxidizer, and the hydrogen will be the fuel. Methyl hydrogen will be the fuel. That's for liquid rockets. But now they are all flying in the indigenous rockets like PSLV, GSLV, and Mark III. And subsequently, we got a technology called the cryogenic technology, the cryogenic propulsion system, where the liquid oxygen and liquid hydrogen, liquefied oxygen and liquefied hydrogen are being used. The liquid hydrogen, the boiling point of liquid hydrogen is 20 Kelvin only, and the boiling point of oxygen is at about 90 Kelvin only. So you need to handle these things at 20 Kelvin and 90 Kelvin. It's very important. And the density of hydrogen is 1/14 of water. It's about 70 kilogram per meter cube only. So then all these properties make your life a little challenging. And it's a highly inflammable hydrogen. And you need to ignite the mixture at a particular mixture ratio. They are all very important. Yes, I'm very glad you understood that. See, the liquid engines, the combustion chamber, the temperature inside the combustion chamber is something like, I think I'm warranted to close the session at the earliest. Okay. Now the temperature inside the combustion chamber is very less, very huge, like something like 3500 Kelvin. All the metals will melt at that particular temperature. So you need to have some jacket cooling. Make the hydrogen itself to cool the chamber wherein it is getting inside, and then supply the oxygen into that. So that becomes a combustion mixture. But even then at that high degree of high temperature of combustion, the chamber does not melt. Otherwise the melting point of that material will be in the order of only 1500 Kelvin. So these are all the important metallurgical phenomena which is happening in a rocket. And then you need to have control. One is chemical propulsion. Propulsion alone is not sufficient. You need to shape the vehicle aerodynamically, and you are going through starting at zero velocity, static from the earth, and you keep going with transonic velocity, subsonic velocity, that is less than the velocity of the sound, and then go cross the velocity of the sound, what's called transonic velocity, then you go to supersonic velocity, then you go to hypersonic velocity. So ultimately, when the rocket is placing in the orbit, geostationary orbit, when the spacecraft is rotating, it goes with a speed of something like 11 kilometer per second at 36,000 kilometer altitude. Assume 11 kilometer per second, we can come from Tirumangalam to your AMC in 1 second. So imagine that speed. So that is the speed with which all these satellites are rotating. I mean, they are all orbiting. So I just touched the tip of the launch vehicle and the spacecraft technology for you. Just I given a teaser to you so that you will keep going through the material, and I am available for any consultation. I request Professor Gnanasekar, John Packiyaraj, and Vice Principal, and Ma'am, Professor John Zebraj, and all this, you can contact me. I've left my card with your principal. And I also welcome all of you to my institution there. You make an industrial visit to our campus, enjoy the campus, know more about our activities. I'm leaving the material with you. You can circulate among yourselves. It's not confidential material. I'm just the published material only I'm bringing to you. Go through, probably with my interaction with you, and when you go through the material, you'll be able to appreciate and understand in a better way, I feel. So, at the end of the food, you add salt to the food, always. More salt is not good. Without salt, all salt is not good. So let me add a little salt to the food. Whatever we do, whatever technology I speak, is all possible with human beings. And to you to get into the shoes, we are not a robo. I told Professor Daumani Christopher that today I am a robo. I'll follow your commands today. So, but then in real life, you can't be a robo. You have to be a human being. And for that, I used to always tell the students, I will add only a little bit of salt. The advice is something like cutting your nail. You should not cut too much, it will bite you. And you cannot leave the nail uncut also. So, we have to have some quotients in our life to have a complete integral person. Like I always used to say, many of you skip breakfast and all. Especially the children when you are rushing for your college bus, and also teachers, I understand. She is looking at me like this. 8 o'clock class. So the physical quotient is very important. I'll just introduce some 4 quotients for you. You integrate all the 4 quotients and take a result out of it. So you need a good physical quotient. So eat well, have your good breakfast. Now I've been seeing that pyramid of food also. Visit that stall and how to eat. They have exhibited very nicely, and discussed with Dr. Priyadarshini also. And I think that physical quotient should be there. You do some good exercise, have some clean habits. Especially at this age, let us not fall prey to some unclean habits. I just urge the youngsters. Now, unclean habits, what I mean, even watching mobile beyond the due time is undue. So, get into clean habits. Keep your physique ready for work anytime. You should be flexible, eat well, do good exercise, have clean habits. And then the next quotient is the intelligence quotient, which is IQ is always, you are all aware. And this institution, I am sure that every one of you will have index 1 in that. So, read well, gather the data, and keep doing things. And the third quotient I introduced to you is the emotional quotient. Be friendly. Have a good harmony when you are there in the classroom. Don't have divisions, don't have partitions, and don't have egos. Especially who will smile first or who will wish first. That's a big ego among us. And especially when you are studying at home, when visitors, guests come to your house, receive them, welcome them, receive them, give them, offer them a cup of tea by yourself. Your mom and dad will feel very happy for sharing their burden. So have some emotional quotient. Be friendly with people. I have lived my career for 35 years. 21, at the age of 21, I joined my institution, and I am now 56 plus. So myself and your principal, we were all 1965 born people. So I've learned one thing: to be friendly with very pleasant mind is always good. It keeps you healthy, and you add value to the system. And nothing wrong if you wish first, and nothing wrong if you smile first also. I've gathered so many school-going children in my street. When I get into the car at 8:15, some students will go. I smile at them. Sometimes I give them some toffees also. Some of them call me uncle, some of them call me tata also. The kindergarten students, on seeing my gray hair, they call me tata. And there are some Malayalis nearby. They call me Appupan. Appupan is tata in Malayalam language. So have a good emotional quotient. Nothing is lost, when you are idling or when you are idle, or you don't keep compartments. Remove all your compartments, but have good friends. There is a saying, it's a beautiful English saying, that good friends makes good friends. Okay, have appropriate friends around you. Keep it open whenever needed to be opened. Otherwise, that friends will always help you. And then the fourth quotient, what I would like to introduce is spiritual quotient. Now, you would have seen the fear of God is the beginning of wisdom. That's what is always we listen and we say, every religion, every faith, we say the fear of God gives you wisdom. That's the beginning of wisdom. So I asked somebody, what is fearing God? Oh, everyone will have different answers. To fear God is what? And I have one answer to you. Be faithful in confidence. If you are faithful in confidence, you will have தமிழ் எப்படி சொல்றது, அந்தரங்கமாக இருக்கும்போது உண்மையாக இருக்கிறது. When nobody is watching at you, be faithful. That is faithful in confidence. When your teachers are not looking at you, be faithful. When your parents are not looking at you, be faithful. So when you are faithful in confidence, that will become a practice in your life. இல்லையா? டீச்சர் சார் பார்க்குறாங்க அப்படின்னா அது ஒரு பாடி லாங்குவேஜ் கொடுப்போம். சார் அப்படி கடந்து போனதும் இல்லையா, சரிதானே? என்ன தம்பி, சார் உட்காந்துருந்தாங்கன்னா ரொம்ப ஸ்டிஃபாக இருப்போம். நம்ம சார் கிளாஸை விட்டு வெளியில் போனது நம்ம பாடி லாங்குவேஜ் மாறிடும். நத்திங் தட் யூ ப்ளீஸ் ரிலாக்ஸ் தட் வே. டோன்ட் பி ஸ்டிஃப். டீச்சர்ஸ் வரும்போது அவங்களுக்கு ரெஸ்பெக்ட் கொடுத்து இருக்கிறோம். தட் பாடி லாங்குவேஜ் இஸ் ரிக்வயர்ட் to respect people. I am telling, and when people are looking at us, we behave or we pretend in some way, but when people are not looking at us, we be natural. So let that natural behavior be good, be faithful. So you integrate all these four quotients, success is with you, and you will be a very useful person. And when you look at the mirror by yourself, you may be tall, short, fair, otherwise, but the inner man, what is in you, the soul, is more important than the external man whom you look at. This is mortal, but the inner man is immortal. So the value should be added to the inner man who is immortal, or inner person. It's a unigender word. Inner person is more important than the physical person what you are seeing in anyone. So if your inner person is really good, you are good. So let me wish all of you a very happy endeavor in your institution, in your studies. A lot of job opportunities are there in ISRO. You can, after your graduation, you can join in your respective field, or you can join in the management field also, in the administration, purchase, stores, accounts. The door is wide open for you. You have to knock the appropriate door. And for making you to come inside the door, there are institutions who are coaching. Join them. Go through the advertisements of the previous years, and we have published in the portal the question papers of the previous years and the answer sheets. Answer sheets, of course, there you can find out. Answer keys are also there. So go through, not only ISRO, I will tell you, go through every job opportunities for you, and make use of the opportunity. Opportunity is plenty available in front of you. So I would, as your principal told, I wish you that all you, the AMC crowd to whom I am addressing, should occupy good positions in your career and have a happy life, have an enjoyable life, and a person of strong inner man. Thank you. All the best.
Thank you very much. Thank you, sir, for your inspirational and motivational talk. Towards the end, the need of the hour, in the era of globalization, always seniors always feel about the future of youngsters, because a lot of technology is freely available. How cautiously that must be used. So in that sense,
our expert has ended his talk with the tip of values that must be inculcated among the youngsters. Okay. So thank you very much, sir, for your inspirational, motivational talk. And he has touched upon many fields of real experiences that we can have. Many things you are studying from the textbook, but how far all the knowledge that you are gathering is tested, is converted to skills, and how they are meticulously used in achieving many technological developments of our nation. And there are a lot of challenging tasks is before you. So how far you take it up and transforming your knowledge that you are gathering from the formal education to skill will decide your future. Okay. Now maybe may I call upon at least few questions or clarifications that you like to have or interact with our expert. One or two questions, please. Yeah. No bar. Yeah. Many times we used to say no question is a silly question. All are, so don't think that way. All are, yeah. Please. Come on, at least, yes, please.
And the reserve fuel, what is available with you, that is very important. When you are going to a nearby altitude, 200 kilometers, you are giving a good velocity, injection velocity, then you can get all your rocket falling into the ocean. But long distance, where is the energy? Energy you can derive from the sun through the nuclear. No, I'll tell you. Nuclear energy, people are, we are getting into that phase. But the safety of the entire system need to be taken care of. We are working for that, but the controlled burning, and you are occupying a space which others also have been occupying. So you cannot create a disaster. That's why so far India, we have not entered into the nuclear regime of space flight, but certainly we will also come up with a nuclear regime of the space flight in the coming years. We are working out how to go safely. Good question. But right now, what we do now, we are taking care of, harnessing the solar energy. So solar energy, the limitation in the power. So with that available limited power, we are going. And the new technologies are getting developed, the electric propulsion system, the plasma thrusters, they're all getting evolved. So soon we are going to test them on flight, and we are trying to apply them for the long distance flights. It's a good question. Nice.
Any more questions? Any clarifications? Yes, please. Yeah, it's part of it. Visible. Yeah, visible. It's one part of the whole spectrum, And any other? Yeah, from girl side. No questions. Come on.
Any clarification from teachers?
Yeah.
I would personally
Yes.
thank you, sir. You have really ignited the minds. Ignite the mind is something that I've seen somewhere. We got really ignited. I'm sure that our boys and girls will prepare. All right. Thank you so much. It makes the whole thing very simple, even to a non-physics much clear with his explanations. I enjoyed every bit of it.
Very kind of
Thank you so much.
that
And,
motivates me.
I'm sure with the PowerPoint backup, these guys will learn a lot because they are all specializing in that particular field.
I request you to kindly.
One request that you can, if you don't mind, you can leave your number with Professor Gnanashekhar.
Yes, sir.
Because we all will feel that it's difficult to approach the principal to get a number. And you
Okay,
can't.
okay. It's the administrative head, obviously.
Yeah.
We have to find.
So, Professor Gnanashekhar is, I call him Raman of American College.
Oh.
By the way, Krishnan is actually a board student, sir. So, my guru is Professor Gnanashekhar, though he's younger in age.
So you have any? Yeah. Yes. Thank you, sir.
Thank you.
Yes. Any more questions? Anyway, I think they will contact you through mail. Okay. Thank you very much. Now, I hand over the session to the.
Thank you, sir. It's the time to thank. We are extremely pleased to thank our esteemed guest, Dr. J. Asir Packiyaraj, for his thought-provoking words of wisdom. Thanking you wholeheartedly for the enlightenment you provided. Thank you so much, sir. A bouquet of thankfulness to Dr. K. Gnanashekhar for moderating the session. Thank you so much, sir. The event wouldn't have been extravaganza without all your presence. Thank you, my dear friends, for your participation. Thank you, one and all. Refreshment is available. We are now breaking for tea. We'll get back again in the next 10 minutes.